So we're coming out of the biggest recession that we've seen in living memory, in fact more than living memory. 2008, 2009, the economies of the world crashed, and governments around the world are looking for ways of driving growth. They're looking for ways of driving growth, developing jobs and sustaining those jobs. So how can the oceans contribute to that issue? How can ocean research and ocean science support that issue? So we're running a project here in Edinburgh that spans the European Union, it spans the United States and Canada. And this Atlas project is looking at better understanding deep Atlantic ecosystems. Because if we understand those ecosystems, we may be able to develop proper strategies to manage them in the future, to sustain jobs and growth in a future blue economy right across Europe. So to do this, Atlas is taking a whole variety of scientific approaches and social scientific approaches, underpinned and linked by the ocean circulation of the entire Atlantic Ocean. This is called the overturning circulation of the Atlantic. Now that overturning circulation is projected to slow down in the years to come. Those projections are robust, but they're debated and argued over, and year to year we see more variability in that circulation than we do at the extremes of the projection. So that makes working out what's going to happen to Atlantic ecosystems that are all connected by that overturning circulation rather difficult. So that our way through that is to build a partnership with government agencies, with international agents from the States and from Canada, with scientific organizations, from universities all the way through to research labs, to come together on the issues of how Atlantic ecosystems function and how they may change in the future. To achieve its objectives, Atlas has developed a whole series of case studies, we call them, right across the Atlantic. We've actually selected 12, and they cross the basin, the whole basin of the Atlantic, from northern Norway through the mid-Atlantic ridge to the United States, the southeastern United States, and the Davis Strait off the northwest of Canada. So it's a very, very big project, but that distribution of case studies allows us to look at a variety of Atlantic ecosystems, from sponge grounds through seamounts, hydrothermal vent systems, and ecosystems formed by deep-water corals. With that variety of ecosystems, we can ask all kinds of questions about the diversity of life in those places, how that varies from place to place, how that may change if those currents change, if that overturning circulation changes, and also how they're related genetically one to the other. There are incredible sequencing approaches out there now, which we can use. We can apply genetic sequencing techniques to barcode the diversity of life in those places and to look at the relationships between the populations. So for the first time, we should know how connected those Atlantic ecosystems are. Then we can really create protected areas and understand how one protected area is related to another over the Atlantic Ocean. And at the final stages of the project, I'm really excited that we're going to take the outputs, work with Dynamic Earth here in Edinburgh in Scotland to develop new outreach facilities, a whole new gallery which will travel around the European Union explaining what deep Atlantic ecosystems are all about and how they may change in the future.